Hey, it's Hendrix here with the answers to the 2023 BC Calculus exam. Question number one, asking it's a Riemann sum question, table question, asking us for the meaning of this integral. The meaning is the number of gallons of gas that flowed into the tank from time 60 seconds to 130. The only thing that's tricky here is making sure you just did 60 to 135 and calculate the Riemann sum as shown. You don't even have to actually multiply it out if you don't want to. Must there exist a value where f prime equals 0? The answer to that question is always yes, but you had to make sure you saw the average rate of change equaled 0, and since f is differentiable and therefore continuous, that statement is a must. Otherwise, they will not give you credit. And then by the mean value theorem, so they're giving you 1 point for having that difference quotient, 1 point for the conditions and mean value theorem explanation. C, average value of a function. So we're just trying to find the average value. That is the integral divided by the interval. And hopefully you got that. Units are the same as G of t, so gallons per second. D, ask us to find the value of G prime of 140. Well, we can just do math 8 and get that value. They want the units, so gallons per second per second. And it says the meaning of this is at time equals 140. That is important. You have to mention at 140. The rate at which the gas is flowing into the tank is decreasing by 0.005 gallons per second per second. All right, on to the second question. Question 2, it is your 2D motion question. Find the acceleration vector. Well, it did make you actually pretty simple questions. I think don't fall into the trap of thinking you have to take these derivatives by hand, even though you could pretty easily do so. You did have to take one derivative to find dy dt is 2 cosine of t, and then you could use math 8 to get those two values right there. The next one, finding the speed, which when the particle is 1.5, you need to use your speed equation right here. So basically your dx dt squared plus your dy dt squared. Take the square root of that and set that equal to 1.5. Put that in your graphing calculator, and you should find the intersection at 1.254. Find the slope of the line tangent to the particle at time equals 1. All right, they asked two questions in this one. So they're asking your slope of the line, that's your dy dx at t equals 1. So dy dt at 1 over dx dt at 1. You can just do that pretty easily and get 0.63. Your x-coordinate of the position, well, we had an initial position of 1 and plus our displacement in the horizontal direction, which is our dx dt times dt from 0 to 1, and we end up getting 3.342. Total distance traveled, that is your speed times time, gives you your total distance, and we're going to go ahead and integrate that on every value from 0 to pi, and we end up getting 6.035. Hopefully nothing too tricky about any of those questions. All right, on to 3, the differential equation question. This time they give you a differential equation with a word problem. So some milk is doing something, being warmed. Smacks of the potato question. Seems a lot like that one. If you would have done the potato question from a few years ago, it's almost the same question. All right, you end up just plotting the point and just making sure that you follow the lines, and you should have a horizontal tangent line right there, and that's basically what you should do for that one. Line tangent. Anytime we do a line tangent, you're just looking for point slope. So we need a point and a slope. It already gives us the point right here, 0, 5. The slope, we just plug in 5 into our differential equation here to figure out what is the rate at which the milk is changing right at time equals 0. And so we find that it's 35 fourths. And so we have this equation. If we just plug in our m of 2 is going to be approximately 35 fourths times 2 minus 0. You obviously don't need the minus 0, but I put it there just because it's going to the inclusion of the point slope, plus 5. And so when we do that, we should get 45 over 2. But feel free, if you left your answer just like that, the college board's counting it, just make sure you put the units. Write an expression for the second derivative. All right, this one, the same as the potato question, and even I think the water flowing out of the barrel question from a couple years ago. You take your derivative. It's easier if you go ahead and distribute first. When we take the derivative, remember the derivative of m is dm dt. So we have to make sure we say negative 1/4 dm dt. And so that turns out to be negative 1/16 times 40 minus m, which is always less than 0, which means that our tangent line will be an over approximation because we're going to be concave down. You don't need to mention that it's concave down. You just mention that your second derivative is less than 0 for all times t, and therefore part B is an over approximation. Using your separation of variables. Wow, they even give us separation of variables. They don't just tell us solve for m of t. I think College Board learned their lesson on that one. So now they're going to go ahead and tell us separation of variables. All right, so we separate our variables. Then we take the antiderivative of both sides. I probably kind of forgot to put my integrations in there. We end up, when we do that, we're going to end up, make sure you remember your simple u substitution. You have a negative natural log of 4 minus m equals 1/4 t plus c. I prefer to go ahead and get rid of the natural log first. What we do there, we multiply by -1 first, exponentiate both sides with e, and when we do that, the minus c becomes a constant coefficient k. Makes this a lot easier to solve. Plug in our initial condition, and we end up seeing that this coefficient of e to the negative 1/4 t is 35, and you can solve for m, and that is your equation. There are other possible answers. If you left it with net logs in the logarithm, there's a lot of different answers, but this is the cleanest. All right, on to the f prime analysis question. No tricks really here. Does f have a relative minimum or maximum at 6? Well, f prime did not change signs there, so it has neither a min nor a max because f prime does not change signs at 6. On what open interval, if any, is f concave down? If we're looking for f prime is decreasing, so f prime is decreasing from -2 to 0 and from 4 to 6. Question C, when you're given a limit, you're pretty much looking at L'Hopital's rule. So you have to first show that the limit of the numerator and denominator are both producing a 0, and then you can go ahead and use L'Hopital's rule and take the derivative of the numerator and the denominator and get an equivalent limit. And so we do that, and then once we take the derivative of the numerator and denominator, we can plug in 2, and it works out to being 3 if you work it out. Absolute minimum. All right, so we're looking at a candidate test. So consider where f prime changes from negative to positive and endpoints. So I did that. These are the 3 different candidates that we're going to look at. Now we're just going to find out f of x at those. The problem was even easier because they gave you f of 2. And so then you just had to realize, compute those values, and these were what they were, 3 and then 11 and minus 2 pi. And so the absolute minimum value is not x equals 2, it is 1. F of 2 equals 1. 1 is the key component there to that answer. Question 5, kind of an area of volume question, a little bit. It wasn't too terrible. It says find the graph of f and g are shown. It gives us the equation for g. It also tells us the area under f, the integral of f from 0 to 3. So if it wants to find this area enclosed, we're going to find all of the area under f, which we know to be 10, and we're going to subtract off all of the area from g, and that should leave us with what we have. Realize it's a pretty simple integral. It's just make sure you do your natural log antiderivative, and you do not need to simplify it. So you can just leave your answer right like that. Evaluate an improper integral or show that the integral diverges. All right, so first off, you had to make sure you understood what g squared was and didn't get crazy with that and just realize that is just 144 over x 3 plus x squared. You don't want to FOIL or multiply this out. It is a much easier question if you don't do that. And so you can just realize that's going to be your integrand, integrates to this. And we need to make sure you put the limits. Hopefully you put the limits on there. They will not give you credit for doing an improper integral if you don't use a limiting process. You have to realize this integral equals 0. And so you end up with just 44 over 3. h, and when it's asking you to find out what is this integral from 0 to 3 of h of x dx, and it told us that h was this right here. That looks a lot like an integration by parts. There's no u sub you can do there, so it is an integration by parts. So you got to find what part are we going to take the derivative. Obviously the x, the antiderivative of the f prime. We set up our integration by parts formula. Just compute the u's, du, your dv and v, and then plug it in. And what do you know? It gives us this integral. And this is actually, excuse me, this is from 0 to 3. And it gave us that value right there up earlier in the problem, so we don't even have to compute that. Then we just have to compute 3 f of 3 and 0 f of 0. Well, 0 f of 0 is going to be 0, so we know that's 0. But we can compute f of 3. It gave us that one earlier in the problem. So it gave you a lot of the information that you needed. Hopefully you were using all that information, or you were looking up here and saw you had that value and that value earlier in the problem stem. Question 6. It's asking for a fourth degree Taylor polynomial. Hopefully you know your Taylor polynomial formula. So we need to compute the fourth derivative. So computing the fourth derivative, it is going to require a product rule to do so. It requires the product rule. And so doing that, and we plug in, we should get -6 for our fourth derivative. That's one answer there. But then once the 6th degree Taylor polynomial, it already gives us the first derivative, the value of the function, the first derivative, the second derivative, yes, it gives us that. So negative f of 0, if you plugged 0 into this equation right here, you're going to end up negative f of 0. Well, f of 0 is 2, so it's just -2. And then the triple prime, which you realize it's going to end up being 0 because you end up having a 0, right? You have -2 times 0. So it's going to end up being 0, and so we don't have that. So then whenever we go ahead and make our Taylor polynomial, it's just going to be 2 plus 3x minus 2x squared over 2 factorial. There is no x to the third term because our third derivative at 0 is 0. And then our fourth derivative is -6. So we have minus 6x to the fourth over 4 factorial. Everybody's favorite Lagrange error bound on the fourth question. It told us the maximum value. So hopefully you knew your formula, which is the maximum value of the n plus 1 derivative over n plus 1 factorial times the distance from the center that we're going to approximate to the n plus 1, which would be the fifth power. And when you plug that in, you'll find that difference is less than, and basically this right here. And you can tell that this is less than 1 over 10 to the 5th because this right here is 1 over 10 to the 5th. And so we know that 120 is greater than 15, so we definitely know that this is less than 1 over 10 to the 5th. Moving on to the last question. A second degree Taylor polynomial. So hopefully you knew that one. This one looks like it might be weird, but actually it works out very simply. If we go ahead and plug in 0 into our first derivative, you're going to find out that you get e to the 0 times f of 0. F of 0 was given at the beginning of the problem was 2. So we get our first derivative at 0 is 2. Now all we do is got to find the second derivative. Well, our second derivative, we're just going to have to use the product rule. And so our product rule yields this e to the x, f of x, plus e to the x times f prime of x. And so then we're going to plug in 0 into that. So we get e to the 0, f of 0. F of 0 was given right at the beginning as I believe it was, what, 2? Is that what it was? Yeah, 2. And then f prime was given as 3. So 2 plus 3 is 5. And so we have our g of 0, g prime of 0, and our g double prime of 0. So our Taylor polynomial should be that. Hopefully you found that useful. Thanks a lot. Hope you got those answers.